Okay, let's look at this question. It's a sporting event. This event is called the high jump. So you need to show the energy conversion at point X. So point X is the greatest height. So it's potential energy or gravitational potential energy. At point Y is quite easy. So it's kinetic energy. So you put kinetic here. And then, of course, when the person impact the landing pad, there's sound produced. Sound energy. Okay, so it's quite straightforward, half mark each. Okay, next we proceed to the more challenging event. This is called a pole vault. This event is actually quite difficult to perform. Okay, and you need to explain why the landing pad used in this event called a pole vault needs to be thicker than this in the first competition, the high jump. So I'd like to show you one interesting physics video on the science behind pole vaulting. So you just sit back and relax as I do the screen sharing for this event called the pole vault. You can see the video here. I enlarge it for you to see. Okay, you can see the video, right? This part. Screen share. I will play it.
And there's the new collegiate record. Mondo Duplantis.
LSU's men's track and field star, Mondo Duplantis, just set a new intercollegiate record for the indoor pole vault at 19 feet 5 inches. There's an incredible amount of physics involved in executing the pole vault, but to really be good, you have to have the speed of a world-class sprinter, you have to have the ability of a long jumper, the agility of a gymnast, and the flexibility of a ballerina. Let's see how he put all of these things together to execute his record-setting jump.
The reigning world outdoor champion from last year in Beijing.
I mean, it's the only record he's had.
It's amazing this actually works just based on simple conservation of energy.
The person is running at a high speed, 9.6 meters per second. So we're going to charge in front and see what's happened.
That all of the kinetic energy starts with ends up going into the gravitational potential energy at the top.
So at the top is only gravitational potential energy.
So Mondo starts about 40 meters back from the pit, runs as fast as he can, in his case around 9.6 meters per second, greatly increasing his kinetic energy. He then plants the bar at takeoff and it converts that kinetic energy into stored electrostatic.
Okay, this one, electrostatic, is actually equivalent to our elastic potential energy. Okay, this part, the elastic potential energy. So the kinetic energy, as you run forward, as he plunges the pole into the hole, right? Kinetic energy is converted into elastic potential energy.
Potential energy in the bar. The bar then bends and acts like a loaded spring. The bar unwinds, giving him that electrostatic potential energy back into kinetic energy and, more importantly, gravitational potential energy, which then lifts him up toward the bar. And then at the peak, notice how he goes over the bar feet first, and he bends his body into the shape of an L. This actually lowers his center of mass, and his center of mass can then pass actually beneath the bar. This gives him an extra 5 to 7 inches in height, of which he can add to his jump. And since
You see, it's highly technical. It's almost like it's actually upside down, this part. Vertically opposite.
I'm someone who's involved in materials research at LSU. This is only possible due to the elastic properties of the material in the pole. If you look at how the men's pole vault world record has varied over the years, around 1920 or so to 1940, it was hanging around 4 to 4.5 meters in height.
Okay, due to the invention of fiberglass, this has helped the world record to increase significantly after 1958. Fiberglass was invented and used in pole vault in 1958. You can see the jump right before that is only 4.5 meters. And then the record shoots up to about this part. 95.5 now have already exceeded 6 meters.
But then in 1958, fiberglass poles were introduced. Now the poles are even more advanced. The fiberglass is reinforced with carbon fiber composites, which make them extremely light and extremely flexible. So they're really good at transferring all of that initial kinetic energy into elastic potential energy and finally gravitational potential energy. So considering how complicated the pole vault is, it's impressive that a simple physics calculation can predict the height of Mondo's record-setting jump.
Okay, so that part, let us return back to the questions. So here, this event called a pole vault. Okay, explain why the landing pad use is thicker. So the answer actually is, you have to mention that, okay, because the athlete jumped over, right, and fell from a greater height, 5 meters. So I will screen share and show you the answer here, this part. Okay, so you write down here, the athlete jumped over and fell from a greater height of 5 meters. So at this greater height, right, more gravitational potential energy is converted to more kinetic energy. Okay, therefore, a thicker landing pad, right, is needed to cushion his fall to prevent any injuries. So the examiner is looking for this part, more GPE converted to more KE. So the thicker landing pad is to cushion the extra kinetic energy during his fall, okay, to cushion his fall to prevent any further injuries. Okay, so I've shown you the YouTube video in this question, and I do a screen recording that I've done already. I will send this answer to you shortly. So today we will pause here. Now it's 6:03. And I will send you the answer of this question shortly. See you then.